Hello and welcome to the Rubik's Code Lab. This channel is about algorithm engineering, not memorizing names, not solving for applause, understanding how ideas evolve. Today we are exploring the maximum subarray problem. At first it looks like a simple array question, right? But underneath it's a deeper idea. How do you make optimal decisions while scanning the data only once? We'll start from the naive approach, we'll measure its cost, we'll observe the redundancy, and then we'll compress that reasoning into a single pass solution. By the end, Kadane's algorithm won't feel like something you have learned. It feels like something you derived. But before we dive deeper into this algorithm series, let's list down what we will go over in this video. Starting off with the problem introduction, we'll see some real life examples. We'll move to the brute force approach, understand its limitation, and then we'll move to the optimized Kadane's approach. Most importantly, we'll look into the time complexity analysis, and everything would be covered in this notebook. So let's start by addressing the question and the array. So we are given an integer array and we need to find a contiguous subarray, meaning elements next to each other that gives the maximum sum. Well, if you pause this video and try to find the maximum subarray, you can come out with an answer 6, and the subarray would be 4, minus 1, 2, and 1. But let's understand in a different way. Let me rewrite this question. Let's make this practical. Imagine you are running a food stall in a 9-day event. Each number represents the daily profit or loss. Negative numbers means bad days. It could be rain or low crowd. Positive numbers means good days, heavy footfall. Now ask yourself, which continuous stretch of day will give you the maximum profit? You wouldn't randomly pick days, right? They must be consecutive. And if the first few days cause loss, you wouldn't carry that burden forever. At some point, you reset and restart. That restart behavior is the heart of Kadane's algorithm. So let's go into a brute force approach. So we'll try every possible starting index, right? Then then with every possible ending index, and then we'll calculate the sum of that subarray. This works, but let's analyze the complexity. We have three nested loops if you look closely: 1, 2, and 3. And that gives us order of NQ. Consider if the array size is 10,000, this will not survive. Even optimizing the inner sum to remove the third loop gives you order of n square. Still too slow, right? Let's try running this and see what it gives. Well, you get the answer. It works, but it's inefficient. Now let's think differently. If we go back to our Navratri example, if your cumulative profit becomes negative, should you carry it forward? No, right? Because a negative running total will only reduce the future gains. So the moment your running sum becomes negative, you reset. That's the entire optimization. So here is an optimized approach for the Kadane 1D algorithm. We maintain two variables. If you look closely, we have current sum and we have max sum. The current sum is the best subarray ending at the current position, and the max sum is the overall best seen so far. At each step, we decide, is it better to extend the previous state or start fresh from this number? So this is where exactly this line encodes that reset logic. Let's try to run and see. Well, it still gives you the answer. Now let's take another array, -5, -2, -8. Notice something important. Even when all the elements are negative, it still works because we initialize with nums of 0, not 0. This avoids incorrect results. Now let's look into the complexities, time and space complexities. We traverse the array once. If you look closely here, we have traversed the array only once. No nested loops, time complexity is order of n, and space complexity is order of 1. This is optimal. You cannot do better than linear time because you must read every element. Let's continue further, taking a few more real life examples. Well, imagine a cricket player's run across the matches. So I'll maybe say Sachin's score, or a better way would be runs. Which consecutive matches should take from? You don't include the poor matches if they drag down the total, right? You restart from when it improves. That's Kadan and Acme. This algorithms appear simple, but it teaches a powerful pattern. Discard the harmful history. Well, uh, as we are done with the Kadan 1D algorithm, I'll put down a few pointers. In interviews, never jump directly to Kadan. First, explain the brute force, and then explain why it fails. Then you can derive the reset logic. So this will give you the structured thinking, and this is what interviewers evaluate. So today we have covered problem intro, intuition, real life reasoning, brute force solution, optimize order of an approach, time complexity analysis. Kadane's algorithm is not about memorization. It's about recognizing when negative history should be discarded. Well, it's a good life lesson as well. So in the next video, we'll build on this foundation and we'll go over to a Kadane 2D algorithm. See you in the next lab.